All right, Math 2, here we go. We got lesson 13-1, volume of prisms and cylinders. So throughout this unit, we will be doing volume. So our question for today is, how can you tell which facing is the base in a prism? All right, so let's talk about our units here as we're looking at length, area, and volume. When we're talking about length, we say that it has one dimension because it kind of just has like a direction, and that's it. And our units in this are going to be like, if this was inches, it'd just be inches to the first or just inches. We're just measuring from one point to another, and it's inches. So it's always going to be to the first power. The length dimension is kind of like a pencil mark. You know, it doesn't have any width to it. It doesn't have any depth to it. It's just from here to here. That's it. When we talk about area, though, area is in two dimensions. So it has a length and it has a width when we're doing area. And so if I was describing, if this is a pencil mark, then area would kind of be like paint. Where you're painting across something. It doesn't really have a thickness to it, but it'll cover up, an area, I guess. That's what it's called, area. So if this was 3 by 3, then we would do length times width to find area, and we get 9, and our units would be in inches squared. Because what we are actually looking at when we're doing area is how many squares are inside of the object. And this is why it's inches squared, because we're looking for squares. How many individual squares would fill up the object there? So again, it's like paint. There's no thickness to it. So this is always going to be units squared. Now volume is in 3 dimensions. So it's got length, it's got width, and now it has depth to it. So here I've got a volume problem where I've got these squares here, and they have depth to them. These squares have a depth of 1. So it's still going to be 3 times 3, and then since there's only one row of them, it's going to be 9 inches cubes. Now when we're looking at volume, we're asking ourselves how many cubes will fill up the space. Over here we're looking for how many squares filled up the space. Volume is looking for how many cubes. That's why it's inches cubed. How many cubes are filling up the space? So here I can see, I can just count it out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 cubes there. So it's 9 inches cubed. So the units are always going to be to the third power, because the third power is the cubed power. Now if I change this problem slightly so that I stack another row of cubes on top, my height now becomes 2 over here. So now instead of having 9 cubes like I had before, I've got 9 cubes plus another row of 9 cubes, so I'd have 18 cubes. So the first two numbers here, my 3 times 3, are kind of like my area. And then the third number here, the 2, is how high am I stacking those areas. I've got one stack on the bottom, and I've got another stack on the top. So I'm multiplying that area by 2 and getting 18 individual cubes. So length, like a pencil. Area, kind of like paint. Volume is kind of like we're filling up an object with like water or something like that. It's got length, it's got width, and now it has depth to it. That's the third dimension. All right, so we're going to look at 2 specific shapes today. We're going to look at a prism, and then we're going to look at cylinders. So prisms are a solid figure, meaning that they are 3-dimensional, with 2 congruent polygonal bases. So polygon just means it has to be made out of straight sides that are connected by parallel lines. And so just like we were looking over here for volume, the volume is just going to be the area of the base times the height. Because in these two problems, the area of the base was 9 and then we just multiply it by the height to find out how many of those bases can we stack on top of each other. So here we had 9 for our base, and then we stacked 2 of those on top of each other. So that's why it was 9 times 2, which is 18. And so with most of our volume formulas, this is going to be the basic formula to it. We're going to take the volume and take the base area, and then multiply by the height. And the 2 bases are going to be parallel to each other. So they're going to kind of be floating above each other, connected by parallel lines. So example number 1, we've got a rectangular prism. So whenever we have a prism, it's usually going to have 2 names with it. The first name is the shape of its base. So here we know that our base is a rectangle. So that's why it's called a rectangular prism. Knowing what shape your base is important because in the formula, we're supposed to find the area of the base and multiply by the height. So which face is the base? So you might say the very bottom is the base. So that the bottom is 2 times 4. So that area down there is 8. So that might be the base. But that's not the only base possible. We could make this side over here 4 times 5 the base. And then the height would be 2 right here. Because I've got another one sitting over here. So I've got 2 bases. And they're connected by these parallel lines here. Now I could even make the front the base. So this front right here, this is 2. And then this section over here would be 5. That could be a base. So in a rectangular prism, any of your faces, the flat areas, can be your base. So you got options. So if we're going to find the volume, let's find it a couple different ways. Okay, we're going to find the base area. So let's pretend that the bottom is the base. So the bottom down here is the base. It's 2 times 4. So we would find the base area.
Attention.
Seriously?
Jaylene Garcia, please report.
All right, they're done. All right, so our base area at the bottom of this base is 2 times 4. There's my base area. And then the height, it has 5. So we're going to stack those bases 5 times on top of each other. So my base area is 8. And how many times am I going to stack it for my height? My height is 5. So I get 40 inches cubed. So there'd be 40 cubes inside of that shape. But what if this side over here, I decided that that was my base? If I decided that was my base, well, over here I've got 5 times 4 for the area. So 5 times 4. And then over here, the height then would be these parallel lines that are connecting this rectangle here with the rectangle over there that's exactly the same. And so I'd have an area of 20 and a height of 2, which still gives me 40 inches cubed. I mean, we should get the same answer. It's the same problem. The last thing I could have decided, I could have said the front. This front portion here was the base. Well, this is 2 here, and this is 5 here. So the area of that base is 2 times 5. And then the height would now be this number over here, 4. And so we'd get 10 times 4, which is still 40 inches cubed. And you can see what's happening here. I'm just switching all these numbers around. So in a rectangular prism, the base, the width, and the height, they don't mean as much in a rectangular prism because they're kind of interchangeable. All right, let's look at the next problem. Triangular prisms. These ones do make a difference. So this is called a triangular prism because the base is a triangle. This first word tells us the shape of our base. So what shape is the base? It's a triangle. Now, since the formula for the volume is the base area times the height. This time when I'm finding my base area is equal to 1/2 base times height. That's the base and the height of the triangle. So let's look at what we got here. So when we find the area, the base times the height, these two things here, this and this, have to be perpendicular. Let's do this color. Must be perpendicular. Okay, so I know since this number here is 4, that means this part up here is also 4. Can I just multiply 4 and 5 and take half of that for the area? No, because this side 4 and this side 5 are not perpendicular to each other. You can only find the area of a triangle by using the base and the height where they are perpendicular. This is not where they're perpendicular. Now I do have over here that this is 90 degrees. So this side right here and the 4 side would be the base and the height because they're perpendicular to each other. I just need to know what that side is. So since this is a right triangle, I can use the Pythagorean theorem. I can say that x squared plus 4 squared equals 5 squared. A squared plus b squared equals c squared. So this gives me x squared plus 16 equals 25. Subtract 16 from both sides, I get 9. Take the square root of 9, and x is 3. So now I just found out that this side is 3. So now that I'm ready to find my volume, volume is always the base area times the height of the prism. So my base area has to be 1/2 base times height. 1/2 3 times 4. So this part here is 1/2 3 times 4. And then the height of the prism is this part over here. These are the parallel lines that are connecting the other triangle that's the same as this triangle on top. So we're going to put 2 right there. So 1/2 of 3 times 4. Well, 3 times 4 is 12. Half of that's 6. And then times 2. So we get 12, and this is in centimeters, cubed. So there would be 12 cubes of centimeters inside of that object. All right, next one. On this one, we have another triangular pyramid. How do I know it's not a rectangular pyramid? I said pyramid. I meant prism. How do I know it's not a rectangular prism? So a lot of people say, oh, there's a rectangle there on the bottom. It must be a rectangular prism. It's not, because these sides are not parallel, and it's not connecting it to another rectangle that's the same size. So I see here that I've got a triangle out here in the front, and I've got another triangle back here in the back. Those are the two bases that have to be congruent to each other. So this is a triangular prism. So the shape of the base is a triangle on this one, which means my base area again has to be 1/2 base times height. Now the height has to be perpendicular to the base. This side is 5 here and this side is 6. I cannot just do 1/2 of 5 times 6 for the area of that base because they're not perpendicular to each other. What I need is to find out what this is. This is the height of that triangle. Now it just so happens that this number over here is also 5. So this is an isosceles triangle because I got 5, 5, and 6. Now the nice thing about an isosceles triangle is the height always splits it directly in half. So this side would be 3 and this side would be 3. So then to find the height, since I've got a right angle right there, and this is a right triangle, I could do height squared plus 3 squared equals 25 squared. You probably already see that the answer is going to end up being 4. I'm at 5 squared there, but you know the difference. So I got h squared is equal to 16, so the height must be 4. So my height is 4. My base is 6. So for the base area, for my volume, I do 1/2. The base here is 6. The height here is 4. And then the height of the prism has to be this 8 over here. The height is always these parallel lines. The heights are always going to connect your two congruent bases together. So my height would be 8. So if I do half of, let's see, this is 24. Half of 24 is 12. And then 12 times 8. So the base area is 12. The height is 8. 12 times 8 would be like 96. And these would be feet cubed. All right, so you might be required to do the Pythagorean Theorem. You might be required to do special right triangles. Remember the 30, 60, 90 triangle where we had B root 3 and 2B, or we even had the 45, 45, 90 triangles where we used A, and A root 2. Or you might even be required to do, trig in order to find the side legs. All right, next one's a cylinder. Cylinder is really similar to a prism, except in a cylinder, the bases are circles instead of being polygons. So the bases are going to be circles. And they're connected by parallel lines, just like the prism. Now, in this case, it's still the base area times the height, but since our bases are going to be circles here, the area of a circle is pi r squared. All right, so on this one, we've got a cylinder where the radius is 5 and the height of the cylinder is 15. So we could say that volume is equal to pi r squared, that's the area of the base, so I'm finding the area of this circle. So I'd do pi times 5 squared. And then I'd multiply it by the height of the shape. Because remember, we're just finding the areas and then filling up the shape using the height of all those other cubes. So this is 15. So 5 squared is 25. So I get 25 pi times 15. And 25 times 15 is 375. That's our answer in terms of pi, meters cubed. In terms of pi means the exact answer. Remember with pi, it's impossible to write down the answer. So in terms of pi is the exact unrounded answer. It's impossible to write down this number, so that's why we use the symbol of pi. So this is the exact answer. Now if I wanted to round it, I'd just take out my calculator. If I was looking to round it, I'd just do, 325 times pi, and it rounds it for me. It's about 1021. So to the nearest meter cubed, we get 1021 meters cubed, approximately. So this is the exact answer in terms of pi, and this is what we get if we round it. Next one. So I've got a cylinder sitting on its side. It looks like a little log or something. You can make a little, not log, a little branch coming off of it. Oh, there's a little branch coming off of the side of the log. With leaves. All right, there you go. So we got a log sitting there. So we want to find the volume of this log. Well, this is the diameter, so my radius would be 3. My height is over here on the side, it's 10. So we're going to do volume equals, the base area is pi r squared, so I would do pi times 3 squared, and then the height is over here. Remember, height doesn't mean up and down. In the case of volume, the height is what connects the two bases. So that's 10. So this is 9 pi times 10, which is 90 pi. And this is in inches cubed. So how many cubes that would be 1 inch by 1 inch by 1 inch? There'd be 90 pi of them. And how much is that actually as a rounded number? Let's see. We should get 282.7. Let's round that up to 283. So approximately 283. Again, exact answer, rounded answer. All right, last couple problems. All right, these are thinking problems. We got to think through this. A rectangular prism has a base area of 26 inches squared. Find the height of the prism if the volume is 65 inches cubed. All right, so we're going to need to use our formula. Our formula is volume equals the base area times the height. Let's plug in the stuff we know. Rectangular prism has a base area of 26. Okay, so our base area is 26. Find the height. I don't know what height is, so that's going to be h. If the volume is 65, equals 65. So what do I do to find the height? Divide by 26. So if I do 65 divided by 26, I end up with 2.5. So the height is 2.5 inches. So I just wrote down the formula and plugged in what I knew. All right, next one says the volume of a cylinder is 48 pi. Find the radius if the height is 3 centimeters. Just 3 centimeters. All right, so this one, our volume is equal to the base area, but in this case, the base area, since it's a cylinder, is pi r squared. So it's the base area times the height. Let's see what we were given. We were given the volume. So instead of V, I'm going to plug in 48 pi. We're supposed to find the radius, so I don't know what the radius is. And I'm given the height is 3. All right, so I need to solve for r. Well, let's get rid of pi on both sides. I'm going to divide this side by pi and divide this side by pi. Pi will go away. So I would be left with 48 equals 3r squared. Okay, I need to isolate the r, so I'm going to divide both sides by 3. And 48 divided by 3 is 16. And then I take the square root from both sides. And we find out that r is going to be 4. So the radius must be 4 centimeters. All right, last one. 2 cylinders have the same volume. The radius of cylinder A is 2 meters, and the radius of cylinder B is 4 meters. If the height of the cylinder A is 4 times the height, oh, there's a lot here. Okay, so let's just start off with, I've got cylinder A over here, and I've got cylinder B over here. Okay, the first part says they have the same volume. Okay, I'm going to write that down so I don't forget. same volume. Okay, that's helpful. All right, it says the radius of cylinder A is 2 meters. Okay, so all of these, I'm going to need equations. So this is volume equals pi r squared times the height, and so is this one. Volume equals pi r squared times the height. Let's see. Okay, so the radius of cylinder A is 2. Okay, so now I know the r value for this one. R value for cylinder A is 2. Okay, that's helpful. The radius of cylinder B is 4. Okay, that's helpful. So I know that that number right there is 4. If the height of cylinder A is 4 times the height of cylinder B. Okay, they're not telling us what the heights are. They're just telling us that this height is 4 times this height. So let H equal cylinder, ooh, I can't spell, cylinder B's height. All right, so this is just going to be H right here. Now it says that A is 4 times that amount. So if H is the height of B, A's height is 4 times that amount. So we would call this 4H. Find the volume of the cylinders. All right, let's see what we have here. We know that the two cylinders have the same volume. Let's clean these up real quick. So I'm going to clean these up. This would be 4 times pi, and this would be 4 times h. So the volume of this one, 4 times 4 is 16, so this would be 16 pi h, right? Let's clean up this one. This one, this is 16. And this is H. Did I write down this problem wrong? Let me double check to see if I wrote down the problem wrong. I might have. I figured out my mistake. I didn't copy down the problem correctly. So this should have been, they have the same volume of 80 meters cubed. And we're supposed to find the heights, not the volumes. Anyways. All right. So I wasn't paying attention, and that's fine. So here's what we're going to do at this point. So we're going to say that this is going to be equal to 80 over here. So 80 equals, 80 pi. Jeez. Okay, 80 pi equals 16 pi times the height. So if we divide both sides by 16 pi, now we can say that the pi's cancel each other out, and we get a height of 5. Now the other height should be 4 times that amount. So let's see if that works. We should over here get a height equal to 20. So we are going to just take away that part right there and that part right there. So over here, we're going to say this is 80 pi is equal to 4 pi times the height. And we'll divide both sides by 4 pi. So we get the height is equal to 20. And it does work. 20 is 4 times as much as 5. The end.